how does Git ensure the integrity of the data in a commit? Okay, so you are committing your changes. For example, here we have commit our changes like this, right? How will we ensure that no one else has the same commit, or we are not conflicting with the other people commit? Because it's a distributed version control system, so many people, they are working on this at the same time, right? So how will we ensure that? How Git is ensuring that? The answer is, I mean, you are seeing on the screen, but yes, with the help of hashing or commit. Exactly. Yes, yes, yes. This one. And there is one more command which I want to introduce you called git log. So there you are seeing this big commit message. And if you see here, go, you see, not 41, I think it's counting the new line characters with echo hyphen n. So this is 40 decimal hexadecimal character. Okay. But before going to that, before pushing any changes to the Git, you need to set up two configuration. Okay. Sorry, I skipped one question. So before going to this one, let me give you some more idea. Anyone who's starting new with Git, before you push your configuration, you need to set up two configuration. One is called name, and the other one is called email. These two configuration you need to set your email ID. Okay, sorry, I will come back to that SHA-1 question again. But anyone know why we need to set these configuration, this username and email? If you don't do that, Git will not allow you to push your commit or commit your changes. So you must need to set these parameters. Why do we need to set these parameters, username and user.email? Yes, identify who made the changes in the repo. Unique identifier, yes. So basically, in simple language, if I can tell you, credit of your work. So like you guys have mentioned, who is doing the changes, right? I will set, okay, I will set this parameter like this, git config user.name p lakera, right? So this guy p lakera, and then I will set the email ID like whatever be the email ID, p lakera at gmail.com. So many people, they are working on this Git project. So who is going to take the credit of all the work who is doing? Like I am pushing the changes. So that file is owned by me, or I mean, I have wrote that code. So I will get the credit of that work. So that is the main idea of setting these variables, user.name or user.email. Just to remind you guys, it has nothing to do with the authentication. Authentication is handled differently. This is just that it is going to put your name over here. I can give you an example here. So, for example, let's go to this repo, go to any of the file if I have, okay, and go to this revision history. Not this. History. So you will see that this file is committed by this particular user. So we will know that who committed this file. So that is the main idea behind setting up these parameters, to know who made this commit. And again, in the long term, this will help us to identify, for example, if this file is creating any issue, whom to contact. Okay, so if this user has committed the change and that has created some issue for us, it need to keep track of that particular person. So that is the main idea behind that. And before moving further, I want to give you guys two alias. Let me put that in a chat that I'm going to use frequently. And these are not created by me. I just I got it from, when I started my Git journey, I got this alias from Stack Overflow. One is called this one. Okay, I already set it up. That's why it is throwing me this error. And the second one is this one. These things help me a lot. So I will explain to you guys what these alias are doing. So simply in case of Linux, if I need to set up an alias, so let's say I don't want to run this ls-l command again. I'm just giving a simple example. This might be applied to any command. I created an alias. Alias means shortcut, right? So rather than executing this big command, I can, rather than in future, if rather than executing ls-l, I can just type L and this will create a shortcut, right? Similarly, in case of Git, you can create these kind of a alias. So rather than executing every time this git status command to get the status, I can just type git s. It will create an alias for me, right? Similarly, this is a long alias. Basically, this is giving you, for example, git log. We have looked at this, which is checking our history in Git, right? Who committed this change? What is the commit hash, the date, and all this information. So this is a long alias which is giving me everything in one line. So I can say one line, which is now it is giving me much more concise output, right? It's having for all the branches. We will discuss about this in the long term. It's showing me graph. So if I run this, for this simple change, it does not make any sense. But if you look at some other repo, let me show you. You will see this is showing me in terms of graph. Okay, and last option is decorate. It even decorate all those things. So for big repos, these kind of alias will be helpful. And this is one example I'm giving you. You can do it on the command line, but most of the like a graphical editor, either VS Code or there's one more called Git Tower, which is giving you all this thing. So this is if you are like a command line ninja who wants to do things in Git, but same thing you can do it with any graphical editor. So rather than, let's say, git commit command, you don't want to use this git commit command again and again. So you can create an alias like git config -- global alias c, and in that you can add this command like commit -m. So rather than typing this big command commit -m, you can just put c every time, and that will save some of your time. Okay, so in this, for the next 2 days, I'm going to use this alias a lot. So just want to show you guys this one. Let's go back to this. Okay. So this is fine. Like we are setting some configuration and alias is fine. We are setting up this alias and this is the alias. But there's something which we are setting is called -- global. Okay. And if you want to look at this setting, you can do something called git config -l. And it will list out all the configuration or alias that I have set. And it is getting stored somewhere in something called git config. Okay. There is something which is still missing. Anyone know what is the use of this -- global parameter? So in case of Git, you can set up these parameters at 3 levels. One is called local, second one is called global, and last one is called system. Okay. So local means local for this particular repo. So let's say this project which we are working, this testing.git, or I can give you one practical example. I was doing a consulting for, let's say, some XYZ company. And for that particular company, in that git config.user.email, I need to use the user ID of that particular company. Okay. But for the rest of my project, I can use my Gmail ID or anything. So for that particular project, if I need to set up this configuration like this, I can do at the local level. So for that particular repository, I have the username set up, whatever that company gave it to me, and the email ID, the same thing. But in case I want, like for each and every project for that particular user, which is a Pilakera user, I want a configuration to be set. So for example, whatever change I'm going to push it to the Git, they all should have the username at Pilakera and the email ID is pilakera@gmail.com. I will set it up at a global level. Okay. And the last one is the system level. Irrespective of anything, global applies for this particular user. But anyone who is working on that particular system, they should have this email, username and email ID. Generally, we don't set it up this username and email for the system configuration. I can give you another example. So for example, is a parameter called co.editor, and I will set it up as a view. So anyone who is logging to that system will have this, sorry, not global system, will get the default editor as a vim when they are going to open the Git. I will show you how this happened. This will apply to the system level. So how this is useful? I can give you one of the practical example that I have seen. That again, I was doing a consultancy for one of the consulting firm, and they there we are working in shifts. So we are following the follow the sun model, FTS model, and the single computer is shared by three different person: the morning, the evening, and the daytime shift, right? So in that case, that single computer have this configuration set up so that anyone who logged into that computer will get this configuration from Git. So that is just a rare case, but only in those cases we set it up at the system level. Local, I told you, like if you are working on some specific project, you can set it up at a local level. Generally, we set it up at a global level so that when I logged in as a user P Lakera in that particular system, that has get all these configuration. Okay, let's come to the main question again. So we have seen that Git is doing a commit, right? We have seen this commit. Okay, we have seen that it is like a 40 hexadecimal SHA-1 hash. Okay, and any one of you thinks like why Git is creating this big SHA-1 hash? So again, I can give you the example of the SVN world. In SVN, we used to do SVN check out the particular repository, for example, https://svn.example.com. And when I'm done with my changes, I can do SVN check-in, whatever the message I need to give, and I push the file. And I got the revision number 1 or revision number 2. But in case of a Git, we are getting this big hexadecimal number. Why do you think we are getting this big hexadecimal number rather than Git can simplify it like revision 1, revision 2, something like that? Why do you think Git is creating this big 40-digit hexadecimal number?
I think this is to uniquely identify each commit. This hash is created
Uh,
by taking into consideration all the changes, I mean, all the files. Then this value is created, this particular value is created. But I'm still not sure why we don't have simple like rev1 or rev2. Yeah, we
yeah,
can identify that way as well.
exactly. So the one of the difference between, I mean, you're on spot on, but the difference between SVN and Git is like, again, go back to the same thing which we have discussed earlier, distributed version control system. So in SVN, we know that everyone is checking to this repo, getting the changes and committing it back. But Git, like I told you earlier, we have the concept of this working, staging, and repo. And remote is something different, like GitHub and all those things. So everyone is working in their area, right? So in order to avoid that conflict, like you guys have mentioned, uniquely identify the commit or try to avoid that conflict, Git is giving that big number to avoid conflict in future. Okay, I will come back to the collision part again, but before that, let's try to understand how this commit has been created. So when Git is trying to create a commit, so let's say again, I have this file lot like test1.txt or test2.txt. Okay, this I started with git add. Okay, and then I do the git commit those changes. So what Git will do, it will create a commit object out of this file. And when I'm using this word create commit object, I mean this SHA1 hash. It is creating this SHA1 hash. And the way it is creating this SHA1 hash, it is taking both of these files, which we are committing. And on the top of that, it is adding something called a metadata. What metadata is that? That include the author who is committing that file, a timestamp, right? And this is the first commit we are committing to this. But in case if this, let's say this is test1, test2 txt, and after that we have modified this test1 file, or let's say we have added one more file called test3.txt after committing this change. So for test3.txt, these two are the parent commit. So it also taken into account the parent commit also. And after mixing all these things like the file name, this metadata and everything, what it is resulting, it's a commit hash, which you are seeing on the screen here. We have this commit hash. And we will talk about this head and master. It also taking into consideration this author name, this email ID, the timestamp when we have done that. So that's why it is creating this completely unique hash. Okay. Again, okay, let me show you this, and you might never need this in future, but just want to show you one thing. If you run this command called echo hello world, we all know, right? This will display the thing to the screen, right? It's just prompting you back to the screen. If let's say inside that text.txt file, we have this content, hello world.txt. And like I mentioned, Git, what it is going to do, it is going to take this content, right? Add all this metadata information and put it inside this low-level command called hash object. Okay. And then it is going to, here I'm just showing you in terms of reference because this input is coming from the standard in. It is going to create this big SHA1 hash for you guys. So this is a low-level plumbing command, which many people don't know, but just want to show you how Git is creating it under the hood, right? So basically Git take all these things into consideration, and so that this SHA1 hash is unique for all the users, because it not only contains the content, because you will understand that this hello world can be anyone else have the same file, but all the other information, author, timestamp, parent commit, that is pretty difficult to replicate, right? I will show you. I still understand that you guys have some doubt, but let me go further and then I will tell you what exactly this one. So again, coming back to that 40 hexadecimal bit, the advantage of using this bit is like, if I change even a single character in this, let's say rather than using small h hello, let me make it capital H hello. You see that it created a completely new SHA hash. Even a single change in the character, it created a new SHA1 hash for you. Okay. Now, this ensures the integrity of the data. Like even when you trying to pull a data from Git, some of you are aware that we use git clone command. At that time, also Git check if the SHA1 hash is correct or not. If not, it will say that the data will be tampered while pulling that data from that remote repo. So this big SHA1 hash try to get that integrity. Okay. The other advantage of that, and you probably heard, and I have a practical experience for that, that when we migrated our repo from SVN to Git, and let's say in SVN, it has a size of like 10 GB. In Git, it will become 1/10 of it. And we are going to discuss it tomorrow, like why exactly that, but just throwing some idea. So in Git, if anyone, like say I have this repo, which we are working right now, it's called testing.git. And inside that testing.git, I'm just throwing some idea. And we have this folder one, and then we have this folder two, and I have n number of folder inside it, like folder two. And let's say in each and every folder, I have a file called test.txt. And then we have this called abc.txt or bac.txt. And each one has the same content, hello.world. I mean, it's highly unlikely, but I'm just giving you some idea. So Git has nothing to do with the file name. It can be anything. It can be prashant.txt. It can be anything. But Git is basically a content tracker. It knows the content that inside that file, it has a hello world. And the way it knows the content, because for the hello world, the SHA-1 hash for this particular repo is always been the same. So what Git do intelligently, that even we have this hello world like 100 times inside this Git repo, it will just take it as a one time. It is just going to reference it one time. It know intelligently, okay, the same content is been replicated 100 times inside this folder. So that is how it is saving this much amount of space. So if this file has 1 MB and multiply by 100 MB, but for Git, it is just a 1 MB file, because inside Git, it is just taking the references one time. It is not storing that file 100 times. And that is where you will see the advantage. Now, I know you guys might have some guys might have some doubt that is this SHA-1 cannot be collide, or someone else in the world will create the same SHA-1 hash and then try to do that. I mean, try to make the same commit. So I can give you this. Let me give you this one. So one of the Google engineers, he tried to do the same thing. He tried to, I mean, guys can go through this talk, but the gist of it, that they will be able to create this SHA-1 collision clash. And what I mean by that, I mean, this is just a simple example, but they, with the help of some really powerful computer, they will be able to generate the same SHA-1 hash for the content, let's say for the hello world. So they will be able to do it like they said, that with the same metadata, all this information, the exact perfectly, even the timestamp within the second, they will be able to generate this SHA-1 hash. So what Git is doing right now, earlier they used to use SHA-1 hash algorithm. But now, starting from I think 2020, even for GitHub, they started moving to SHA-256 hashing. So that is one thing. If you guys have time, just go through this doc and it has all the information. And the last thing is the immutable commit. So what this SHA-1 hash is doing, like I mentioned you guys earlier, it is not only the content of these file, the metadata, as well as the parent commit. Like, for example, like I told you, if you checked in these first two files and after that you are committing this file, this test1 and test2 is become a parent commit for this test3.txt. So test1, test2, you committed in one go. You did git commit, git add and git commit. And once you commit these two files, you committed test3.txt. So for test3.txt, this will become a parent commit. So in the SHA-1 hash of this test3.txt, this will become a parent commit, right? So it will generate a SHA-1 hash based on this parent commit also. So even a single change of in any of these parameter, it is going to generate a new commit for us. So that is how the commits in Git is a kind of a immutable. If you change a single parameter in it, like we have seen the small h versus capital H, it created a completely new SHA-1 hash. So that is how the Git maintain all the integrity of the data using this big SHA-1 hash. Okay.